Assalamualaikum and a very good day. So today we are going to look on chapter 5 on the chapter estimation. Okay, so the aim of this topic is to construct the confidence interval for the population means. So for this chapter we only focus on single mean. Okay, so when we talk about the estimation, so there will be a confidence interval. So the question will ask you to construct the confidence interval of 90% or 95% or 97%, 98% or 99%. Okay, so we have 90%. So when your confidence interval is 90%, that means your confidence coefficient is 0.9. So how to get this 0.9? 90% divided by 100. 90 over 100, then you get 0.9. So when your confidence interval is 95%, so that means your confidence coefficient will become 0.95. When your confidence interval is 97%, that means your confidence coefficient is 0.97. When your confidence interval is 98%, that means your confidence coefficient is 0.98. When your confidence interval is 99%, that means your confidence coefficient is 0.99. Okay, so the formula of the confidence coefficient. So this is your confidence coefficient 0.9. So the formula is equal to 1 minus alpha. Okay, this one is very important. Okay, you have to memorize the formula of confidence coefficient. That means it's equal to 1 minus alpha. That means when we talk about the confidence interval of 90%, okay, then we know that the confidence coefficient is 0.9. Okay, the formula to get the 0.9 is equal to 1 minus alpha. That means your alpha is 0.1. Okay, it goes same for 95% confidence interval. So we know that for the 95% confidence interval, your confidence coefficient is 0.95. Okay, so how to get the alpha? We know that the formula of the confidence coefficient is equal to 1 minus alpha. Then you get your alpha is equal to 0.05. So it goes same to the confidence interval of 97%, 98% and also 99%. Okay, so now we look at the formula of the confidence interval for single mean. Okay, now there are two types of your sample. The first type is for the large sample and the second type is for the small sample. Okay, so sigma is none. That means your standard deviation is none, or the standard deviation is unknown. Okay, so for the large sample, okay, when your n is greater or equal to 30, okay, when the question given the standard deviation, that means you know the standard deviation, then you must use this formula. But if the question does not give the standard deviation, that means your standard deviation is unknown. So you must use this formula. Okay, so now what is the difference? This one is standard deviation, this one is standard deviation, this one is also standard deviation, but this one is S. Okay, the difference is that the standard deviation for the population is the sigma. The standard deviation of the sample is S. Okay, that is the difference. Okay, that means when the standard deviation of the population is known, you use this formula. When the standard deviation of the population is unknown, but you are given the standard deviation of the sample, then you use this formula. Okay, now if we look at this formula, okay, we have Z alpha divided by 2. So this Z is from the Z table, okay, or standard normal distribution table. Okay, now let's see, we have the question for 95% confident interval. So the question asks you to construct 95% confident interval. Then we know the 95% confident intervals. Okay, we have the 0.95 confident coefficients. So by using the R1 minus alpha formula, then you get the alpha is equal to 0.05. Okay, now this alpha is equal to 0.05. Okay, then we divide by 2. Then you get z is equal to 0.025. Okay, please keep in your mind, z 0.025 is not the critical value, but z 0.025 is the probability. Okay, is the probability, and we are going to look for the critical value of the z table. Okay, now we look at this example. Okay, now we are looking for, okay, okay, now we are looking for z alpha divided by 2. Okay, so your alpha, let's say, is 0.5 divided by 2. Then you get 0.025. Okay, this 0.025 is not the critical value. Okay, what does it mean with the critical value? This one is your critical value. Okay, but this 0.025 is the probability. So this one is the probability. Okay, so now your probability is 0.025. Okay, then we want to looking for the critical value. Okay, now 0.025 is the probability, so it's around here. Okay, 0.025. Okay, so we are looking for 0.025. Okay, now we have here 0.025. Okay, so we have the probability 0.025 is here. So what is the critical value? Okay, it's 1.9 plus with 0.06. Then you get 1.96. Okay, so your Z 0.025 is equal to 1.96. Okay, now we already have this value. Okay, Z alpha divided by 2 is equal to 1.96. Okay, okay, now so the X bar is the mean of the samples. Okay, so D sigma, okay, is the standard deviation of the population. The N is the number of sample. Okay, so okay, this one is Z alpha over 2 is the 1.96. Okay, we already calculate just now. Okay, for 95% confidence interval. Okay, then the standard deviations of the population and also the number of sample. Okay, so for this one, S is the standard deviation of the sample. Okay, then N is the number of sample. Okay, so we are going to use this formula to solve our problem. Now we look at this example. For this example, okay, suppose that we have 100 samples of water from a freshwater lake. Okay, that means we have number of sample, our N is equal to 100. Okay, so the average is 0.66. Okay, that means this is your X bar, okay, your mean, okay, of the sample. And the standard deviation is 0.049. So that means we have the sample and we have the standard deviation of population is unknown, but our standard deviation of the sample is known. Okay, we use the S. So we must construct a 95% confidence interval. Okay, that means your confidence coefficient becomes 0.95. Then your out. Okay, now so we have the n is equal to 100. Okay, which is greater than 30, so it's considered as a large sample. That means we are going to use the Z table. Okay, so we have the x bar 0.66 and we have the s. Standard deviation is the standard deviation from the sample. That means we used our s is equal to 0.045. So we want to construct 95% confidence interval. That means 0.95 is equal to 1 minus alpha. Then your alpha is equal to 0.05. Okay, so this is the formula for the large sample and your standard deviation for a population is unknown. So we have the x bar minus z alpha divided by 2 as n. Okay, so now we want to calculate the z alpha divided by 2. Okay, so we already have the alpha 0.05 divided by 2, then we get 0.025. Okay, so by looking at the z table, we are looking for the critical value, okay, of the z table, then we get 1.96. Okay, so we substitute 1.96 here. Our x bar is here 0.66. Then our standard deviation of the sample and the number of sample. Okay, then we simplify, then we get this estimation of the confidence interval.